For our fourth page on the Chapter 3 practice test, we're dealing with word problems. And to get you started here for number 13, we're talking about quarters and dimes. We could let Q be the number of quarters. We could let D be the number of dimes. And remember what we said when we first covered this lesson. We said there was always one equation that dealt with how many, a quantity of items or people. In this case, it's the first sentence. A coin bank contains 62 coins, quarters, and dimes. So we could say that we have Q plus D is equal to 62. From here, we can very quickly realize our second equation deals with money. And we're going to, in these coin problems at the very least, always work in pennies. So a quarter is worth 25 cents. A dime is worth 10 cents. And add those two together, you'll have $10.40. You could even multiply by 100, 10.40 times 100. It would move your decimal place 2 to the right. But that means you have 1,040 pennies, 1,040 cents. Now, what you need to do is do elimination to make this problem work out a little nicer. So I'm going to multiply this top equation by negative 10. And I'll have negative 10Q plus negative 10D equals negative 620. Down below we have 25Q plus 10D equals 1,040. And hopefully you can see the canceling of the 10D and the negative 10D. 25Q plus negative 10Q is 15Q. And of course, if we were to get some help with the calculator, negative 620 plus 1,040. Well, you can even do that quickly without a calculator, of course. 420. Divide by 15. You can just hit divide by 15 right now. You'd get 28. Now, what you know is you have 28 quarters. However, you do know that the number of coins together is 62. Some kids will just do common sense and say, well, you know that 62 minus 28 has to be the number of dimes, if you've got 62 items total. Other kids feel more comfortable going back to that original equation, plugging in your Q. Either way is good. You're going to get the same answer, of course. Borrowing over here, I think you can see pretty quickly you'd get 34. So you'd have 34 dimes. Best of all, you can very quickly check and see if you are correct. You can say, well, if I've got 28 quarters, that would be 25 cents. If I have 34 dimes, each one of those is 10 cents. You can say, how much money do I have? 1,040 pennies, which, by the way, is $10.40. Well, let's take a look at number 14. A group of 28 people go to a restaurant, and the adult buffet costs $10 a person. The children's buffet is $8. You're trying to find the number of adults, the number of children. So you could say let A be the number of adults. You could let C be the number of children. Now, of course, the first sentence here is one of how many, a quantity. It means you've got 28 people. Like I said earlier, you're always going to have an equation dealing with quantity. Add up the number of coins, or add up, in this case, the number of people, and you will come together to 28. The second equation must be with money. Each adult is charged $10 at the buffet. Each child is charged $8. We don't have to convert from dollars to pennies or vice versa. Everything is in dollars here. But I do hope that you can see immediately that our C's could cancel out. What would cancel an 8C? Well, I hope you could see we'd really like to have a negative 8C. So I'm going to multiply by negative 8 to get negative 8A, negative 8C. You can think, well, gosh, what's negative 8 times 28? It would only take you a moment to see it's negative 224. And down here we have 10A plus 8C is equal to 258. These C's are gone. Here you have 2A. And, real quickly, negative 224 plus 258. You can see it's only 34. Well, when you divide by 2, you'd get 17. You have 17 adults in your group. Again, common sense could say, well, if you've got 28 people and 17 of them are adults, kids can quickly subtract in their head, and that's all well and good. Other kids want to go back to the original equation, and they'll say, you know what, substitute in a 17, and then solve. By the way, you'll do the same thing. And as you solve for the number of children, you can see you'd have 11. Again, the wonderful thing is you can double check if you have the right number of people and also the right amount of money charged. Last one. A group of 18 friends goes to a ball game, but they cannot sit together. Some of them sit in the mezzanine seats, where it's $38. The rest of them sit in the bleachers, where each seat is $20. Total cost is $576. Well, you can let M be the number of mezzanine. And of course, we could let B be the number of bleacher seats. And of course, we're implying people sitting in these seats, really. So that's where the 18 friends come into play. M plus B. Add up all the mezzanine seats, all the bleacher seats. You get 18. That's your quantity equation. But each mezzanine seat, talking about money, now we're going to deal with the cost. $38 for each one of those. Each bleacher is $20. And all together we'll get $576 total. Well, nearing the end, hopefully you can see we could easily get rid of the B's here. What would cancel a 20B? Well, a negative 20B. So we'll multiply by negative 20 to get negative 20M plus negative 20B. Negative 20 times 18 is negative 360. You can, of course, check that. But without too much work, I hope you can see that you will be left with an 18M. The B's are going to be gone. And you will have 216 on that right side. Obviously, your next step is to divide 216 by 18, and you'll get 12. So they have to purchase 12 mezzanine seats. But here we go again. If you've got 18 friends and 12 of them are sitting in the mezzanine section, it doesn't take much to realize you'll have 6 in the bleachers. Now again, you can go back to that first equation and say, well, if M is 12, could we solve? And, again, you get the same answer, of course. But thankfully, that's it for this final page. Definitely hope things are working out for you.